This is video 3. This is video 3 of cell suspension culture. Now we are going to look after the different types of cell suspension culture. Number 1 is a batch culture. So batch culture is a type of cell suspension where the cell material grow in a finite volume of agitated liquid media. So these cultures are maintained continuously by subculturing. Batch cultures are most commonly maintained in conical flask incubated on orbital platform shaker at speed of 80 to 120 rpm. It is a closed system with no addition or removal of nutrient and waste product during the period of incubation. Now remember that how will you describe a batch culture? Remember that there is a closed system where neither can enter nor can leave. So if we take a flask of if we take a conical flask, we add around 250 ml of plant tissue culture media, liquid media inside it, then we add our cells inside it and we close it. So this is a closed system. And in this system, in batch culture system, we neither add any nutrient nor remove any product. So if that flask is there steadily, and it is called as a batch culture. We are neither removing any nutrient media nor we are adding anything in it. Just whatever we have to add at the start of culture. So now that particular flask is called as closed system and it is known as batch culture. So we incubate that flask on a rotary shaker at 80 to 120 rpm. What happens when we add initial cells inside it? They start growing inside that particular flask. And after a certain time period, such as 21 days, the flask is completely filled with the cells. So it is known as a closed system. Okay, kindly remember that. If we look at the growth, you might have studied this type of culture in bacteria or growth curve. If we look at the cell number and time of this particular batch culture, then initially lag phase where we actually start this culture, then the cells start slightly growing, we call it as an exponential phase. Then there is a linear phase where as the time passes the cell number increases. Then there is a stationary phase. After that stationary phase, cell number does not grow because still have consume all the nutrients inside that particular flask. And remember that in batch culture we are neither adding these nutrients nor removing any cells. So the still have consumed and slightly then there is a decline phase. So this is a growth curve of what we say batch culture. Now batch culture has again types: slowly rotating culture. Now in slowly rotating culture, in this type of culture, single cells and cell aggregates are grown in specially designed flask, the nipple flask. So I'm going to show you the diagram of nipple flask, and it is recommended that if there is a note on batch culture, then you should draw the diagram of nipple flask. Okay, each nipple flask possesses 8 nipples like projection having a capacity of 250 ml. They are located in circular manner on a large flat disc of vertical shaker. When the flat disc rotates at the speed of 1 to 2 rpm, the cells within each nipple of the flask are alternatively bathed in the culture medium and exposed to air. Now, if we look at this diagram, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there are around 10 nipple flasks which are mounted on a single big disc. That's it, B. Okay, and each nipple flask has what we say media and plant cells. When these flask rotates, the media inside that particular flask also rotates, and then the cells are gradually exposed to liquid condition and what we say aeration condition. Okay, so this diagram is recommended. Okay, now then there is a shaker culture. Now after slowly rotating culture, there is a shaker culture. In this very ineffective system, it is because what happens, nipple flasks are very fragile. Okay, because we have to go for production of production of this nipple flask, it is very fragile. Okay, and when we mount it on a vertical large disc, there are chances of accident and spillage. So it is quite complicated, but shaker cultures are quite simple because in shaker culture it is very effective system. In this method, single cells and cell aggregates are fixed, added in a fixed volume of liquid medium and placed in conical flask, as I have already told you. These flasks are then mounted with the help of clips and horizontal large square plate on the orbital platform shaker. These square plates are moved in circular motion at 60 to 180 rpm. Simply, we have very large rotary shaker inside our laboratory. We use a flask, we add a liquid medium, then we add a cells, and we put them on these orbital shakers at 60 to 180 rpm. So this is a shaker culture. Then there is a spinning culture. Spinning culture is a bit larger system. It is used for the large amount of media, that is around 10 to 15 liter system. You can look at the diagram. Okay, in this there is a large bottles which generally contain 10 to 15 liter of media, and it should also that this media should be half filled. Okay, it should be at 45 degrees Celsius angle. So the bottle should be like, it should contain at least 20 to 30 ml volume which is half filled with the media, and then we add our cell. Now this bottle is mounted on a special rotating device which rotate at 120 rpm. Now bottle is this is a large bottle which is mounted at 45 degrees Celsius. You can look into the diagram. Okay, and then it is rotated at 120 rpm at the angle of 45 degrees Celsius. Okay, so this is a spinning culture. It is generally used for the large scale. Now there is a stirred culture. This system is used for large scale batch culture. It is like a fermenter. Stirred culture system is like fermenter or bioreactor system. In this method, the large culture vessels is not rotated, but the cell suspension inside the vessel is rotated. Now what we have seen inside a spinning culture, the whole bottle is rotated, and when we rotate the bottle, culture inside the bottle also rotate. But in stirred culture, bottle is not rotated. We rotate a culture inside that particular medium, either by dispersing air through inside medium or agitating using magnetic stirrer or any other method. The magnetic stirrer generally revolves at 2 to 600 rpm. It is just like a bioreactor, and here is a design for what we say stirred batch culture. Now there is a continuous culture system. Okay, so now in next lecture, in next part of this video, we'll cover the continuous.